In the name of God, hello class. In previous section we explained about hybrid algorithm. Hybrid evolutionary algorithm refer to those algorithms that uh, is produced by combination of EA and another type of algorithm. It is named as a hybrid algorithm. Hybrid algorithm has more efficient and is faster than EA. For example, the famous hybrid algorithm is named Memetic algorithm, which is produced by combination of uh, EA and local search. So if we combine a local search algorithm and EA algorithm, a memetic algorithm is produced, such as a combination of hill climbing or simulated annealing or another types of local search algorithm that produce better algorithm and enhance the efficiency of EA. We can also combine EA with some artificial intelligence or some fuzzy logic and another type of uh, algorithm. Local search is mean we search in a local area. We compare the fitness of each element, such as D, uh, with the neighborhood of D, such as A, C, H, and we select the better element. It is named as a hill climbing that may be greedy or steepest. In a greedy, we compare the fitness of the each element with the neighborhood, and when we want the better element in the neighborhood, the search stop and we go to the better element. But in the steepest search, we compare the center with all of the neighborhood and we select the best element with higher fitness than center. It is named as a steepest. And we explain about two types of model for life type adaptation or change in the element, which is named as a Lamarckian and Baldwinian. Lamarckian is such some or all of previous explanation is Lamarckian. In the Lamarckian, each property is transmit from parent to children or offspring. In other words, in each generation, individual or children replies and the parent is died. In the Lamarckian, the properties inheritance to the next generation, and each gene or in each property transmit from the parent to the children, such as GA, such as all explanation about the EA that we explained before. But in this page we have new explanation. It is Baldwinian. In the Baldwinian, the property is not transmit from parent to children, but the properties receive or earned by the children during the lifetime. it received from the fitter or better neighborhood. In this, in previous model, each each element replaced by the neighborhood and the fitness increase. But in Baldwinian, each element receive fitness or the fitness of element increase and it reach to the fitness of better element. In this definition, trait or properties acquired by the individual, not transmit, and it is named as a mem uh, that we refer as a memetic. Gene or gen is transmit from parent to children, but mem, such as practice, such as some um, other effect that increase the fitness, is named as a mem. Baldwinian effect cause to better fitness and cause element has better fitness. Also, we have not some limitation, biological limitation in computer, but in the nature we have some limitation in the gene and in the change of fitness. In these plots you see three types of plot or curve. Black line is a raw fitness or fitness function that select the better element for the next generation. Circle, red circle is a Lamarckian point that is exactly the same as a raw fitness, but in Baldwinian method you see in the blue line it's a fitness, and in this plot you can see that the Baldwinian has a better fitness and better result than other type of plots. In other words, in Baldwinian we can improve the fitness. For example, a footballist have some skill by nature from the parents, but some of the skill acquired during the lifetime, and it can increase the skill by exercise, by some uh, sh showing the video and other types of method that can acquire the better fitness or skill. There are many types of local search. One of the local search is hill climbing or hill climbing. Hill climbing it is a climb to the hill or to the mountain. When you want to climb and reach the top of the mountain or hill, you put the first step and the next step in higher uh, height, with more height, and you go higher and higher to reach the top of the hill or mountain. It is named as a hill climbing. In the hill climbing you go upside, not downside. The height is such as fitness, and each time you increase the fitness, not decrease the fitness. It is named as a hill climbing. There are many types of local search, such as taboo search. It is only name that we not explain in this page. Both Baldwinian and Lamarckian decrease the diversity. When the diversity decline, it causes some problem in the EA, such as premature convergence or trap to the local minima, and we must use some technique use such as Boltzmann operator or simulated annealing to avoid the local minima. The key point of this method is refer, for example, when you want to find the minimum error of this curve. It is a minimum error of this curve. If you are, for example, here, the better fitness is a fitness with a lower error. It is error, and you want to find the minimum error here. In Boltzmann or simulated annealing, sometimes instead of you go to the, for example, if you are here, not here, if you are here, sometimes you go to a more error or lower fitness instead of going to the lower error or higher fitness, because if you go to the worst element, you can reach the best element. For example, if you are here, you can go to the down or lower element and find the local minima. But if you go opposite of error or in worst neighborhood, you can reach the best element. Boltzmann method and simulated annealing are two types of local search that in this type of local search, sometimes we do not go to the better element. Sometimes we go to the worst element with lower fitness, because we may find the best result in the neighborhood of worst instead of go to the better element. This Boltzmann method that delta f is the difference between the fitness of current element and the neighborhood. If it is positive, we go to the better element, but if it is negative, for example, the element, the neighborhood has worse fitness than the center, and you go to the worst element by this probability. In other words, we go to the better fitness all times, but sometimes we go to the worst fitness by this probability. At the beginning, we go to the worst fitness, and we accept worst fitness. It is named as exploration. We explore or change. We have more change. It is named explore. But at the end, we go to the worst fitness with very lower probability. It is exploitation, and in other words, at the beginning of a search, we have a risk or explore, and at the end of the search, the risk is in decrease, and we go to the better, not the worst neighborhood. There are many types of local search that can be used for search in the neighborhood, such as Boltzmann machines, such as hill climbing, such as simulated annealing. In conclusion, we reach the last page. The hybrid algorithm is an algorithm that is produced by the combination of evolutionary algorithm and another type of algorithm. One of the most popular algorithms that is combined with evolutionary algorithm is local search. The combination of local search and EA is named as a memetic algorithm. Sometimes of local search such as hill climbing, uh, simulated annealing, or Boltzmann machine is used to combine with evolutionary algorithm. As I refer, the memetic algorithm have a faster and a lower time consuming for processing, and better performance that some only EA. When you use local search or memetic, the efficiency increased. In other words, it can reach the better element faster than when you use only EA algorithm. As I referred in previous page, one of the most important local search is hill climbing. In the hill climbing, for example, in each element, it is a current element, you compare the fitness of the center or current element with neighborhood. If the neighborhood is better, you go to the better. For example, if the fitness is 5, it is 3, it is 4, it is 6, it is 8, 2, for example, 7, 2, and 1. For example, if you start the compare the fitness with this and you use greedy, in a greedy search you start from one of the neighborhood and compare the fitness. It is fitness 5, it is 3, so it is worse. You go to the next. It is 4, it is 5, it is worse. You go to the next, it is 6. In a greedy search, you go to the 6, and 6 is the next element. And you also compare the next element fitness by another, for example, by this, for example, neighborhood fitness. But if you use ST-PEST, you compare all of the elements with current element, and the highest fitness is selected. It is 8. So the next individual, the next element is 8, and it has also some other for example neighborhood, and you go to the 8 and compare the comparison with another neighborhood. It is a greedy search algorithm. In this method of search, you go from one element to better element. For example, the fitness is 5, you go to the 8. 8, you go to the, for example, 9, and you continue to better fitness. It is named such as hill climbing. But in some methods, such as simulated annealing or Boltzmann machine, uh, you do not go to the better fitness all time. Sometimes you go to the, for example, better fitness, and sometimes you go to the worst fitness. For example, you go to the uh, element with worse fitness, especially at the beginning. At the beginning, it is named as an exploration. You want to explore or search, and it is sometimes you go to the worst element. But at the end of the search, you only go to the better element. It is named as an exploitation. Uh, why you sometimes go from one element not to the better element, but to the, for example, worst element? Why? Because we want to escape from local minima. For example, if you want to find the minimum of this curve, the best answer is here. And if you are here, you have two neighborhoods. One is here and one is here. It is a fitness or inverse of error. If it is error, you want to find this error, minimum error, or highest fitness. Fitness is inverse of error. If you go to the better, you trap to the local minimum. But when you go to the worst element, such as this, you can go here and then reach the best element. Boltzmann machine and simulated annealing is a technique used that sometimes you go to the worst element to find the best element. But if you always go to the better elements, such as here, sometimes you may trap to the local minimum.